Satya Namaskar. Noise. Noise is an unwanted sound at a wrong time, at a wrong place. It is a form of energy which is emitted by vibrating body on reaching the ear cause and sensation of hearing through the nerves. Sound produced by all the vibrating bodies is not audible. Frequency limits the audibility is from 20 Hz to 20,000 Hz. Frequency limit of audibility is 20 Hz to 20,000 Hz. Noise is generally consists of three interrelated elements: the source, the receiver, and the transmission path. Transmission path is usually the atmosphere through which the sound is propagated, but can include the structural material of any holding containing the receiver. This is the source, this is path and the receiver. Source, path, receiver. There are two important parameters of the noise. First, intensity or loudness, and second, pitch or frequency. Intensity or loudness, the rate at which sound energy reaches a given cross-sectional area, is known as sound intensity. There is an abnormally large range of intensity over which human can hear. Given the large range, it is common to express the sound intensity using a logarithmic scale known as the decibel scale. The intensity of sound is measured in terms of sound pressure level. Its unit is decibel or bell, BEL, bell or decibel. SPL, sound pressure level 10 log 10 is equal to intensity of sound upon intensity of reference sound. SPL, sound pressure level 20 log 10, pressure of sound upon pressure of reference sound. According to Acoustic Society of America, standard reference sound, SRS, standard reference sound is sound which can be first heard at a sound pressure of 2.04 into 10 to the power minus 4 dyne per cubic centimeter, or 20 micropascal, or 2 into 10 to the power minus 5 Newton per meter square. Acoustic Society of America standard reference sound is which can be first heard at a sound pressure 2.04 and 10 to the power minus 4 dyne per centimeter square, or 20 micropascal, or 2 into 10 to the power minus 5 Newton per meter square. Measurement of the noise level in decibel is carried out with an instrument called sound level meter. Sound level meter. It consists of three international accepted weighing network, namely A, B, and C. Commonly, ambient noise level are measured in the A weight, SPL abbreviated dB. The scale resembles the audible response of human ear. Sound of the frequency from 800 to 3000 Hz are covered by a weight scale. Pressure and decibel. Intensity 10 to the power 12, 10 to the power minus 12. इसका प्रेशर होगा 2 into 10 to the power minus 5 Newton per meter square. 20 micropascal, decibel 0, threshold of hearing. 10 to the power minus 10 intensity, 2 into 10 to the power minus 4 pressure, 200 micropascal, 20 decibel, church and quiet room. 10 to the power minus 8 intensity, 10 to the power 2 into 10 to the power minus 3, 2040 public library. 10 to the power minus 6, 2 into 10 to the power minus 2 Newton meter square, and 20,000 micropascal is 60 decibel, normal conversation limit at 1 meter. 10 to the power minus 4, 0.2 Newton meter square, 2 into 10 to the power 5 micropascal, 80 decibel, heavy machinery workshops. 10 to the power minus 2, 2.0 Newton per meter square, 2 into 10 to the power 6 micropascal, 100 source at 5 meter, 1.0, 20 Newton per meter square, 2 into 10 to the power 7 micropascal, 120 decibel, boiler shop. 0 decibel, threshold of hearing, 20 church quiet room, 40 public library, 60 normal conversation at 1 meter, 80 heavy machinery workshop, 100 source at 5 meter, 120 boiler at 5 meter, or 120 boiler shop. 100 source at 5 meter. Sound, the decibel, source, and noise level decibel. Air compressor 95 to 104. 110 kVA diesel generator 95. Lathe machine 87. Milling machine 112. Oxy-acetylene cutting 96. Pulverizer 92. Rewriting 95. Power operated portable saw 108. Steam turbine 12,500 kilowatt 91, pneumatic chiseling 118, quiet garden 30, trickling clock 30, computer rooms 55 to 60, type institute 60, printing press 80, sports cars 80 to 95, train 96, trucks 90 to 100, car horn 90 to 105, jack takeoff 120. I repeat it. Jack type of 120, car horns 90 to 105, truck 90 to 100, train 96, sports car 80 to 95, printing press 80, type institute 60, computer rooms 55 to 60, trickling clock 30, quiet garden 30, pneumatic chiseling 118, steam turbine 91, power operator portable saw 108, rewriting 95, pulverizer 92, oxy-acetylene cutting 96, milling machine 112, lathe machine 97, 110 kVA diesel generator 95 or air compressor 95 to 104. Inverse square law. The sound intensity or the acoustic intensity is defined as the sound power. The sound intensity or acoustic intensity is defined as the sound power PSC per unit area. Sound power per unit area. First, spherical sound source. For the spherical sound source, the intensity of radial direction as a function of distance r from the center of the source as follow. I is equal to PAC upon capital A is equal to PAC upon 4 pi r square, where AC is the sound power, A is the surface area of a sphere or a radius. Sphere of a radius. Thus, the sound intensity decreases with the 1 upon r square, where r is the distance from an acoustic point source, and the inverse square law states the intensity of sound is inversely proportional to the square of the distance from the source. I is equal to intensity of the sound is equal to PAC. PAC means sound power upon area is equal to PAC upon 4 pi r square for a sphere. Noise intensity is proportional to 1 upon r square. I1 upon I2 जो I2 का स्क्वायर अपन R1 स्क्वायर. Point source. Decrease in the sound pressure level with the distance R1 and R2 from the point source can be calculated by the following formula. L2 is equal to L1 minus 20 log R2 upon R1. L2 point source. Decrease in the sound pressure level with the distance R1 and R2 from point source can be calculated by L2 is equal to L1 minus 20 log R2 upon R1. L1 is the sound pressure level at location 1 decibel. L2 is sound pressure level at a location 2 decibel. R1 distance between the source and the location 1 feet per meter square, and R2 is distance between the source and location 2 feet per meter square. If R2 and 2R1, L2 is equal to L1 minus 20 log 2 upon 1. L2 minus L1 is equal to 20 log 2. L2 minus L1 is equal to 20 into log 2 की वैल्यू 0.3010 होती है. L2 minus L1 is equal to 20 into 0.301. L2 minus L1 is equal to 6 decibel. We can that for every doubling of the distance there is a reduction of 6 decibel. Every doubling distance there is a reduction of 6 decibel. Line source L2 is equal to L1 minus 10 log R2 upon R1. if there is a point source, L2 is equal to L1 minus 20 log R2 by R1, and line source L2 is equal to L1 minus 10 log R2 by R1. L1 sound pressure level at the location 1 decibel, L2 sound pressure level at location 2 decibel, R1 distance between source and location 1 feet per meter, R2 distance between source and location 2 feet per meter. R2 is equal to R1, then L2 is equal to L1 minus 10 log 2 upon 1, L2 minus L1 is equal to 10 log 2, L2 minus L1 10 into log 2 की value 0.301, so it can be L2 minus L1 is equal to 10 into 0.301, and L2 minus L1 is equal to 3 decibel. We can that every doubling of distance there is reduction of 3 decibel. 3 decibel for line source or 6 decibel for point source. Decibel addition. Sound level from two or more sensors can be added by the following methods. Add the several different decibels values are added then sound. L sum 10 log 10 LP110 plus 10 LP210 10 LPN upon 10. Example, efficient sound level from two air conditioners 60 decibel, which will not be 60 plus 60 or is equal to 120. It will be 60 plus 3, 63 decibel by a following method. +63 is equal to 66. 66 plus 66, addition of 3, 69. 69 plus 69, addition of 3, 72. 72 and 57 is higher value 72. This is sum of sound. Shortcut method. Addition of the sound level L1 and L2 when L1 is greater than L2. L1 is greater than L2, the L1 minus L2 dB. Add difference of two L1s 0 or 1 3 decibel, 2 or 3 2 decibel, 4 or 9 1 decibel, 10 or more 0 decibel. The specifically where number of different sources produce same sound decibel, then their cumulative sound will be L sum is equal to LP plus 10 log n, where n is the number of the sources. 10 log n, दो सोर्स है 3 सोर्स है, LP जो है उसमें जोड़ देना है. Decibel subtraction. In some cases, it is necessary to subtract decibel level. For example, if the cumulative levels of the several source is known, that would the cumulative level will be if one or source were removed. Add L difference to 10 log 10 LP1 by 10 minus 10 LP2 by 10. Subtraction. Decibel are averaging logarithm by formula L average 10 log 10 LP10 plus 10 LP210 plus 10 LPN 10 upon n. Frequency pitch. Pitch refers to frequency. Pitch refers to frequency which basically membrane vibrates. Frequency is analogous to pitch. Based on frequency, sound is divided into three classes. Infrasonic, less than 15 Hz, elephant. Audible, 20 to 20,000 Hz, human beings and dog. Ultrasonic is less than 20,000 Hz, bats and whale. Hearing acuity, ability to hear sound with least loudness is called hearing acuity. Ability to hear with sound with least loudness is called hearing acuity. Ideally, it should be 0 decibel. Normal hearing acuity varies from 0 to 10 decibel. We cannot hear high decibel sound if pitch is not in audible range. But best audible frequency is 1000 Hz to 4000 Hz. Audible area 100,000, 4000, 10,000 hertz, and 1000 to 4000. This is audible area. Best audible frequency 1000 to 4000, 0 to 140 decibel. Sound and effects. 25 decibel hearing loss start. 6 to 50 decibel mild hearing loss. 51 to 70 decibel moderate hearing loss. 71 to 90 decibel severe hearing loss, and less than 91 decibel profound hearing loss. The hearing loss start from 25 decibel. 25 hearing loss start, 2650 mild, 5170 moderate, 7190 severe, and 91 profound. Phone. Tone and phone are the unit used in calculating the relative loudness of sound. Tone and phone are used in calculating the relative loudness of sound. Tones are calculated from the nomograms, that interrelated sound pressure level and frequency, and phones are the summation of the zones by special addition procedure. Phone. Unit of sound equated with number of decibel. Unit of sound equated with number of decibel produced at a frequency of 1000 Hz on logarithmic scale. One phone is equal to 1 decibel is equal to at 1000 Hz. Two phone 2 decibel at 1000 Hz. N phone n decibel at 1000 Hz. The zone is scale based on the observation that 10 phones increased in the sound level is the most often perceived as a doubling of loudness. One zone is equal to 40 decibel at 1000 Hz. One zone is equal to 40 phones. One zone is equal to 40 phones. With every increase of 10 phones, there is doubling of zone. 2 zone, 50 phone. 50 decibel at 1000 Hz. 4 zone, 60 phone, 60 decibel at 1000 Hz. One zone is equal to 40 decibel. But next 10, 50 doubling the 2 zone, and then next 10, 60 doubling the 4 zone. Every 10 zone doubles, every 10 phones doubles the zone. Weighing. Human ear does not respond equally to the sound at different frequencies. We tend to perceive sound at a lower frequency as having a lower intensity. 1933, Fletcher and Munson published a set of equal loudness curves described the manner in which the ear responded to the sound at different frequencies. Fletcher and Munson investigated how people reacted to sound played at different frequency at the same intensity. For example, they played a tone at 1000 Hz, then played another at 500 Hz, and a test subject was asked to adjust the second tone until it was perceived as being the same intensity as the first. They then repeated the experiment for a variety of frequency of intensities and developed equal loudness contours for every and each intensity. Building on the initial work of the Fletcher and Munson, we now know that the human ear does not perceive 60 decibel sound at 100 Hz to have the same intensity as a 1000 Hz signal played at 60 decibel. In fact, the ear perceives sound 100 Hz as nearly 20 decibel. Lower in magnitude at the 1000 Hz. To account for, we use a weighing system in the environment noise. Studies by try to replicate the performance of the human ear. A weighing curve follow the general pattern of 40 phone curves developed, and use weighing has becomes the de facto accepted descriptor for environment noise. Weighing decibel. Minus 80, minus 70, minus 60, minus 50, minus 40, minus 30, minus 20, minus 10, 0, 10. 10, 100, 1000, 10,000 frequency. A is weighing curve, and this is C weighing curve. Other weighing, ये ज़्यादा important नहीं है. Noise indices पे आ जाता हूँ. Different indices are used to explain the noise based on loudness, pitch, and exposure duration and noise. Equivalence noise level, LEQ. It is a continuous A weight sound level and that is equivalent in terms of noise energy content to the actual fluctuating noise existing at the location over the observation period. It is also defined as the average rate at which energy is received by the ear during the period mentioned. L equation 10 log 1.t T1 multiplied by 10 LP1 10 plus T2 multiplied by 10 LP2 10. Total time over T1 is the duration for LP1 continues, T2 is the duration for which LP2 continues, LP1 noise level from the first source for time T1, LP2 noise level for second source for time 2. Background noise levels. When assessing environment noise, it is generally useful to establish what is the general background noise level in the area. The best represented L90 or L90 decibel A, which is the level exceeded for the 90% of the time under the consideration. Similarly, L10 is used for the noise level which exceeded for 10% of the measurement period. Correct? In noise level, it is used to incorporate nuisance value of the sound. Correction are applied to measured noise level. So allowances for some of the factors will ignore the person's reaction of the noise. Noise pollution levels L and P. Noise NLP होना चाहिए. Noise pollution level LNP is equal to L equation plus 2.56 standard deviation sigma decibel. LNP is equal to LEQ plus 2.56 sigma. LEQ noise equivalence level, sigma is standard level. Threshold limit value. Threshold limit value for the noise refers to the sound pressure level and duration of exposure to which nearly all the workers may be repeatedly exposed without adverse effect. Threshold limit value for the noise refers to the sound pressure level and duration of exposure to which nearly all the workers may be repeatedly exposed without adverse effect. It is also time based on the exposure time change. The TLV value changes. The table below lists the duration in which the workers may be exposed to a given average sound area, and these limits assumed that the worker is not wearing hearing protections. Duration 62 and sound decibel level 16 over 82, 8 over 85, 6 over 86, 4, 88, 3 over 89, 2 over 91, 1.5 over 92, 1 over 94 and 0.5 over 97 and 0.25 100. Maximum allowable exposure time can be calculated by following formula. Duration is equal to 8 into 10 to the power 85 decibel बटा 10. 82 की यूनिट है. 82 डेसिबल है तो 16 घंटे से होंगे. 85 है तो 8 घंटे तक. 86 है तो 6 घंटे तक. 88 तो 4 घंटे तक. 89 है तो 3 घंटे तक. 91 है तो 2 घंटे तक. 92 है तो 1.5 घंटे तक. 94 है तो 1 घंटे तक. और 97 है तो आधा घंटे तक. और 100 है तो पाव घंटे तक. Duration hours 8 into 10 to the power 85 decibel A upon 10. Noise exposure dBA time weighted average is equal to 85 minus 10 log T by 8. Noise exposure time निकलना है तो निकालेंगे 85 multiplied 10 log T by power 8. Day and night noise level L, D and dB is equal to 10 log 10, 15.24, 10 LP upon 10 minus plus 9.24, 10 LP minus 10 upon 10. Noise number indices NNI. NNI is LPN plus 15 log 10 N minus 80. NNI noise number indices is equal to LPN logarithm average of the maximum perceived level attained 15 log 10 N minus 80. Aircraft noise. An aircraft moves through the air. Molecules near the aircraft are disturbed and moved around the aircraft if the aircraft passes at a low speed. typically less than 250 miles per hour. The density of the air remains constant. However, for the higher speed, some of the energy of the aircraft goes into the compressing the air and locally changing the density of the air. The compressibility alters the amount of resulting force on the aircraft. The effect becomes more important as the speed increases. Near the beyond the speed of the sound, that is 760 miles per hour at the sea level, 330 meters per second, small disturbances in the flow are transmitted to the other locations. Sharp disturbances generate shock waves that affect both the lift and drag of the aircraft and low condition downstream of the shock waves. Mach number. The ratio of the speed of the aircraft to the speed of the sound is called Mach number. The ratio of the speed of the aircraft upon speed of the sound is equal to Mach number. Mach number M allow us to define flight regimes in which compressibility effect vary. Flight regimes in which compressibility effect vary. Subsonic condition occur for Mach number less than 1. M is less than 1. For the lowest subsonic condition, compressibility can be ignored. As the speed of the object approaches the speed sound, the flight Mach number is nearly equal to the M is equal to 1, and the flow is said to be transonic. At some places on the object, the local speed exceeds the speed of the sound. Compressibility effects are most important in the transonic flow and lead to the early blip in a sound barrier. Flight faster than sound was thought to be impossible. In fact, the sound barrier was only an increase in the drag near sonic condition because of compressibility effects. Because of the high drag associated with the compressibility effect, aircraft do not cruise near Mach number 1. Supersonic condition occurs for Mach number greater than 1. Mach 1 is greater than M is greater than 3. Compressibility effects are important for the supersonic aircrafts, and the shock waves are generated by the surface of the object. For high supersonic speed, 3 is less than M and M is less than 5. Aerodynamic heating also becomes very important for the aircraft design. For speed greater than the 5 times the speed of the sound, M is greater than 5. The flow is said to be hypersonic. At those speeds, some of the energy of the object now goes into exciting the chemical bonds between the hold together the nitrogen and oxygen molecules of the air. At hypersonic speeds, the chemistry of the air must be considered when determining forces on the objects. The space shuttle re-enters the atmosphere at high hypersonic speed. M is equal to 25. Under this condition, the heated air becomes ionized plasma of gas and spacecraft must be insulated from the high temperatures. Type of sound or Mach number. Subsonic less than 1, transonic 1, supersonic less than 1 or hypersonic greater than 5, supersonic greater than 1, transonic 1, subsonic less than 1. Impact of noise, auditory effect, physiological or psychological effect, and speech inferences. Auditory effects. Physical changes is not generally possible until they are exposed to a high noise level, but a shift in hearing acuity is very much possible and might lead to deafness. Threshold shift may be temporary or permanent. For temporary threshold, a person should be exposed to 60 to 80 decibel for 18 to 16 hours. Exposure to a 130 decibel noise of frequency 1400 Hz to 2400 Hz for 5 minutes can be bring shift in the threshold of about 40 decibel. Any shift above the 40 decibel or the more can cause acoustic trauma, the physical damage to eardrum, the like rupture and physical damage to organ of aorta. Any shift above 40 or more can cause acoustic trauma, physical damage to the eardrum, like rupture and physical damage to the organ of aorta. In organ cavity, there is about 17,000 of the hair cell. Even if 500 to 1000 cells are destroyed, then hearing change occur. These hair cells cannot be regenerated. Duration of exposure and intensity of the sound are important factor in deciding hearing damage. Occupational deafness. When loss of hearing acuity results from the exposure of the noise in the workplace, damage is gradual and caused by the destruction of the cochlea and not because of the eardrum. Blast deafness, it might lead to physical damage of the eardrum and oscular chain. Tinnitus, it is the ringing sensation in the ear. According to World Health Organization study, 1 to 3% of the worker complained tinnitus at 80 decibel, 11% of the worker complained at 90 decibel, and universal complained about the tinnitus at 110 decibel. Universal complaint about the tinnitus in 110. Physiological and psychological effects of the noise on the fetus physiology: increased movement inside the womb, sudden and sporadic increase in the fetus heartbeat, effect on sleep as per WHO study up to 35 decibel, no complaint. However, 50 decibel and above there is difficulty in sleeping. Probability of those asleep waking up 5% at the 40 decibel A and 30% at 70 decibel A. Speech impression masking. Presence one sound decrease the ability of a person to hear and understand other sound. It is more related to pitch rather than the loudness. Threshold and detectability, noise level which can be detected by receiver as the sound without reference to its meaning. Threshold of integrity, level of the sound required for response to measuring content of speech normally. Normally, threshold of detectability is 12 decibel, lower than the threshold of intelligibility. If noise level goes 40 decibel, then difference between the two thresholds narrow as threshold of the detectability increase while threshold of the intangibility remains same. Speech interference level, it is defined as the arithmetic average of the sound pressure level SPL at 500, 1000, 2000 and 400 octave band. Noise control method: suppression of noise at the source, path control, protection of personal. Suppression of noise source, sound absorption or sound insulation. The performance of sound insulating material is exposed in terms of the reduction index, which is given by R is equal to 10 log 10 P1 1.2 decibel. P1 is sound level of source side, sound pressure level opposite side. Vibration meter, patch control, acoustic enclosure, noise barrier, muffler and silencer. Dissipative muffler or silencer DM and reactive muffler or silencer RM. Dissipative muffler and silencer to reactive muffler and silencer. There is also known as absorptive silencer, work on the principle of absorbing noise and they make use of acoustic absorbent lining. Reactive muffler silencer, this type of silencer work on the principle of reflecting and thus containing sound within them. In dissipative muffler silencer, in terms of performance, dissipative mufflers normally provide sound attenuation over a broad frequency range, hence they are more popular than reactive variety and industrial process plant application. Reactive muffler, they can be of various shapes to provide impedance mismatch where the acoustic energy is reflected towards the noise source. Dissipative muffler silencers, pure dissipative silencers are based on the use of flow resistant material, normally in the form of a porous acoustic lining. Such materials may be used to cover a interior surface, be in the form of a parallel baffles. Reactive silencers are tuned to provide maximum attention at the specific frequency and thus work as narrow band silencer. The latter arrangement can be considered for dissipative muffler as splitting the volume involving into the series of line ducts that effectively increase the absorptive length of the silencer without increasing its actual length, although its diameter may have to be increased. The reactive mufflers, these silencers reduce the radiation acoustical power, principally counting on to the impedance mismatch, allowing acoustic impedances continuity and reflecting sound back towards the source, and its advantage is small size and high mechanical stability. Automatic type silencer, vibration isolation, damping, lagging, and protection of the personal earplugs, earmuffs, or helmets. Air quality standards with respect to noise. Area code A in category zone industrial area, daytime 75 or nighttime 70. B commercial area, daytime 65 or nighttime 55. Residence area, daytime 55 or nighttime 45. Silence zone, daytime 50 decibel or nighttime 40 decibel. This is all about the noise. Hopefully expect that this video should become useful for us.